Hello everyone, you are all welcome to lecture number 1155, that is the role of attosecond in quantum optics, and this year's Nobel Prize in Physics is shared between three scientists, and these scientists they tried to establish that we can take the photograph of electron, very fast moving electron, and it is possible only when we go to attosecond level of speeding. And in physics till today, before their research, it was only possible up to Fermi second means 10 to the power minus 10 to the power minus 15 second. Up to that speed, the light was possible to squeeze, and after this Fermi second means 10 to the power minus 15 second, it was not possible in the light, because light it was not possible for the light to have pulses above that, and because of that reason it was not possible for very fast moving electron to read the electronic movement. So these three scientists, the one name is that is Pierre Agostini. He is from Ohio State University, USA. The second scientist is Frank Krauss, Max Planck Institute of Quantum Optics, Germany. Is a very, very reputed institute of quantum optics. And number three is Anna L. Wheeler. She is female, and she is the sixth female to get the Nobel Prize, and she is from Lund University in Sweden. So one is from USA, other one is from Germany, and third one is from Sweden. These three scientists, they shared Nobel Prize on that ground that is attosecond, that is pulse, and with that pulse it is possible for electron to become free, and we can get the photograph. Actually, the photography of moving object was a big challenge in 1700, some 200-300 years ago. It was not possible by camera that if some horse is running very fast, you can take the photograph whether all his four legs are touching ground or they are up. It was not possible because whatever photo we were getting, it was blurred. It was not crystal clear. So one photographer in 1878, he gave the method of getting moving object photography in crystal clear manner by shutter movement, and by fixing 12 camera with cable, and when horses were moving, he was getting the photo, and in that case he became successful. And then it was very clear that at what point how many legs are touching to surface and how many legs are up, and that photography I am going to show. But before that, let me give his name. Photographer of moving object, his name was Edward Marbrice. So Edward Marbrice in the year 1878 established that photography is possible. And let me share my childhood experience. It was in 58, 59. I was very young. So in my town in India, Balrampur, I was living with my parents, father and mother. So there was lot of excitement talking in my house that now there is motion movie. So motion movie means they are moving, they are in action, but they were not talking. And one film came, and in that film they said that it's very, very interesting. That was Alamara, first film talkative, that my mother and all my aunts and my father, they were talking, it was discussion in the house, that one film is there now, and in that film they are moving as well as they are talking. So voice was also given. It was in 50s in India, in my area. Maybe in other area it might have come by 30s or 40s. So we all went together and we watched the movie, and we were all very much excited to see that man in action, moving, running, horses, they are talking, they are enjoying, laughing. So it was such type of film, and it was possible because of the photography. And that photography became very advanced with manual shuttering. Shutter means just by action. So with that action of shuttering manually, now it is auto shutter. It's taken care by artificial intelligence. Automation is there. So when we are starting our videography, automatically everything is taken care. But some 200-300 years ago, it was not possible. It was a big challenge to have the photograph of moving object. But today there is challenge of taking the photograph of moving electron, and that these three scientists, they have shown that we can do that. Let me show the horse. Like this, here this horse, it is crystal clear. So it is the photo is taken with its shuttering, and that's why you know that but it is not yet very clear once it is running whether how many his legs are touching to surface and how many are in the air. These photographs, this is taken by Edward. It was in 1878 with the help of 12 cable cameras, so that all horses, there are 12 horses, and they are all movement second wise. It is recorded, and that's why they could understand by seeing very clear photo that how many legs are moving at what time and how many are touching to surface. So here, before going to that, the photography or the understanding of the electron movement and how to make the electron to become free, we have to understand the electronic picture. So there is nucleus here, and around nucleus there are different shells, we call them orbit, and one electron is here, one electron is here, and one electron is here. So you have to understand in what type of energy level these electrons are here. So the one which is very close to nucleus will contain less energy, because it is very close to nucleus, and to be binded around the nucleus to move, it is going to cancel some of its intensity of negative charge with the positive charge of nucleus, so it will contain less energy. And if you are moving outer side of the nucleus, it will be containing high energy. So this is the picture of that electron, but this is Bohr model of atom. And when there was discovery of electronic microscope in 1952, and then electronic microscope, so when electronic microscope was discovered in 1952, and they tried to see the photo of very fast moving electron. So what they found, that around the nucleus there are cloud. There are some rare patches of electron, but it was electronic cloud. And that was the maximum probability of finding the electron around the nucleus. So the concept of definite path of electron by Bohr was rejected when the discovery of electronic microscope came in 1952, and they said that there is nothing like fixed orbiting of the electron. They are in the form of electronic cloud, and that electronic cloud was not clear. Only some cloud was there, and that's why it was not possible to give the photo. And then they went on doing the research, and nowadays a lot of research is going on. Everywhere you might be hearing quantum. In the last lecture I discussed the quantum particle. Quantum particle means nanoparticle, 10 to power minus 9 size, nanometer size of the particle or crystal, and its optical property and chemical physical property. Here I am discussing. There they got the Nobel Prize on that quantum particle. Here I am discussing that is called quantum optics, means a nanosecond, femtosecond, and attosecond. And this attosecond, nowadays there is a new branch of physics that is called attophysics. ATTO physics means those properties what they are going to observe with that speed, that object, how they are moving with that attosecond. And let me give you a very clear picture. The scientists, they discover all these things, and the wave nature of the electron, that is called it can behave particle as well as it can behave as a wave by many physicists. It was in the year 1920s and 30s. And again today, lot of scientists are involved in knowing the lot of detail and to understand, to read, to photograph the electron, because electron is the most important fundamental particle of atom. Because all matter is made up of atom. All atom is made up of electron. And electron, once they are sharing, there is molecule. Once they are transferred, there is formation of molecule. Once they are coordinating, there is formation of molecule. So it's all the role of electron in atom to form the molecules. And we have lot of complex molecules. I have already discussed this thing: protein, carbohydrate, fat. So they are all containing electron. So the electronic nature at quantum level, at nano level, at attosecond, their speed is very, very important. That's why nowadays there is quantum physics very much in action. There is quantum chemistry, I call it a nanochemistry, is a very much in action. And there is a new branch of chemistry that is called nanochemistry. There is new branch of physics that is called attophysics. And they are all related to their tiny particle and their time in billionth or trillionth of second. And with that timing, they are going to study how to get the photograph of electron. So to get the photograph of electron, first they have to get the electron free from its shells, inner shells. So how to make them free? So in that case, in the ordinary light, they cannot squeeze the light more than femtosecond. Femto word is Danish, means 15, 1/15th of the second. So after that, it was not possible to squeeze the light into pulses, to knock down, to make the electron to free. And that's why physics was hanging around that. This year, in 2023, these three scientists, they shifted to ultraviolet side, and they created that attosecond, and that attosecond means up to that extent we can create the pulse provided it is ultraviolet, and then they can read the movement of the electron. On that, the Nobel Prize was awarded in 2023. So it is all the photography of these electrons, and also what is the importance of femtosecond. Actually, femtosecond is widely used nowadays in laser surgery. Laser surgery is done, and in many medical colleges they are using this femtosecond, and also in many hospitals where there is very complex optical surgery, means eye surgery, to correct the retina or cornea, they are using femtosecond application of that light which they are going to use. And this, your attosecond, that is 10 to the power minus 18, is used to read and to photograph the electron. So here I have given all these three scales to measure the time, and it is very, very important to get the photo of electron. And getting the photo of electron by using a very, very high speed shutter has created new branch of physics that is called attophysics. Here all the physical phenomena are studied, lot of research is going on in that branch of physics that is called attophysics based, where the light at ultraviolet range pulses are created to get the photograph of electron and its reading, creating fingerprints. Lot of research is coming out. So here nano is a Latin word and is the unit of time. So nanosecond is a unit of time, means 1 billion of second is equal to 10 to the power minus 9 second. If it is 10 to the power minus 9 means, if I can write billion like that, 0. Then it is nanoscale, nanosecond. In the same way, the second is called, that is femtosecond. Femtosecond means it is 10 to the power minus 15 second, and its name is 1 quadrillionth of a second. 1 quadrillionth of a second is equal to 10 to the power minus 15 second, and that is called femtosecond. And the word femto is derived from Danish dictionary word, and femto in Danish means 15. And third one, that is very important, where they got the Nobel Prize by using this, and attosecond. Attosecond means it is the unit of time. It is 1:10 to the power minus 18 second. It means 10 to the power minus 18 of a second. And atto is Danish word meaning 18. So once you put 0.180, once you put 0.18, 0, 0, 0, 0 up to 15. Then it will be 15, 0. If 0.0000 it goes up to 19, that is called atto, is called femto, is called nano. Now the motion blur picture is a result of location of moving object. Why we get blurred picture of moving object? The reason is that at a different location it is not fixed, and that's why whatever light is reflected or emitted is blur, and that's why photography is not possible unless we have very fast shutters, and that very fast shutter is in seconds pulses. That is what they did in 2023 to get the photograph of electron. The motion of moving object, light reflected or light emitted from the object makes blurred picture. If anything is in fast motion, it is not possible to get crystal clear photos unless we use high speed shutters. That is what in 1878 one very famous photographer, Edward, he tried by using 1 dozen camera with 1 dozen cable, and horses were running, and he got the photo. I showed that photo, and it was crystal clear photo. It will be blurred. It is because of low shutter speed. If your low shutter speed is very important, what low shutter speed is there, you will not get crystal clear photo of moving object. It has to have very high speed, like in attosecond speed. It is because of the low shutter speed we need an auto shutter. Only with very high fast shutter we can take the photo of electron. With this very high speed shutter we can get the photo of the electron, and this concept, this type of investigation, finding or research gave birth to new branch of physics that is called attophysics. That is called it is a very new branch emerging physics with technology, with artificial intelligence, and at the same time in chemistry also is a very new branch of chemistry is there, where we are studying the physical, chemical and optical properties of crystals at nano level. That is called nanochemistry. And this year's 2023 Nobel Prize has gone to Attosecond, that is optical quantum study, and chemistry Nobel Prize has gone to the nano size crystal and its optical property. So number one, here I have given in the form of note the same thing what I explained you and I delivered during the lecture. Number one, this year 2023, scientists produce pulses in ultraviolet region because Attosecond that is 10 to minus 18, was not possible at ordinary light. That's why with this they got very fast shutter to take the photo of the electron, and from here the new branch of physics came into action, is called Attophysics, and that 10 to the power minus 19 second that speed of the light was only possible with ultraviolet region, and 1 attosecond is equal to 10 to the power minus 18 second is equal to 1 over 10 to the power 9 multiplied by 1 over 10 to the power minus 9, and here is written here 0 point, then 1801 is second. That is the unit of attosecond. Number 2, the deep ultraviolet pulses can take photos and read the electron and study the wave function of the electron. It is under laser beam. It is under laser beam, ultra fast optic technology. The work is done, and light cannot be compressed more than 10 to the power minus 15 second is the maximum limit. This was in the physics till 2023, but it can be compressed in that ultraviolet. That's why it is attosecond, and attophysics is there. We cannot further produce pulses. That is why the scientists took the help of UV pulses. That is, electron is very important, a basic fundamental particle for atom, for matter, for everybody and everything. Those which are made up of matter, and whole universe is made up of matter, means made up of atom, means made up of electron. And electron is playing very important role in all the bonding properties, chemical, physical, optical, everything. That's why now again lot of focus, lot of research is going on, the quantum, the nano, and the physics, all these areas. And this pulses will take the electrons. Note, these pulses are electromagnetic field, and when these pulses are interacting with the very fast moving electron, will pull the electron from its inner shell. Unless the electrons come out from its inner shell, the photography and reading is not possible. So only these pulses, that is attosecond light compression, will produce the pulse, and that one will release, we will make the electron free, and then we can get the photograph. That is this year's this Nobel Prize, electrons with attosecond speed, and that attosecond speed is 10 to the power minus 18 second, and it is possible to get the photo of electron, and we can read the electron, and with this the new branch of physics came into existence, that is called attophysics. So these three scientists, Nobel laureates in physics, very challenging research, and they are successful to read and to photograph the electron, moving electron, and at the same time they are the one who gave birth to attophysics, the more and more research, so that more and more understanding, photography, fingerprinting, all these things will change the whole physics and chemistry at quantum level in future. With this I will stop. Thank you very much for watching the lecture.